Hey guys, this is Independent Lesson 1.6, Graphically Representing Summary Statistics and Comparing Distributions of Quantitative Data. So the main two things that we're going to talk about first are 5-number summaries and box plots. So as you can see here, 5-number summaries, they're made up of, like the title says, 5 numbers. So the minimum value, the smallest number, Q1, median, Q3, which we talked about in yesterday's lesson, and the maximum value, or the biggest number. And the box plot is how we're going to represent that 5-number summary graphically. So we need to look at how to actually make a box plot. So there's 6 steps to this. First step, we find the 5-number summary of our data set. So this is something that we can find using our skills from lesson 1.5. We're going to label and scale a number line appropriately. You'll notice that in the example, I've already done that for you. You're going to mathematically check for outliers. You're going to graph any outliers as dots above the number line. You're going to draw a box around the quartiles and a vertical line. Extend the line to the smallest value that is not an outlier and the largest number that is also not an outlier. So we are going to find the 5-number summary and construct a dot plot for the following data set that I am going to give. So the data set we are looking at is 13, 14, 14, 15, 17, 18, 21, and 29. So to find the mean for these things, well, we're just adding up everything and then dividing by the amount of numbers that we have. So we have we have 8 numbers. So let's find the mean first. And we're going to do that off to the left here. So remember, we need to add up all of our numbers. We need to find the median, not the mean. Mean is not part of our 5-number summary. So we have 8 numbers. Our median is going to be sitting in between 2 numbers. So if we tick off in between here, our median is going to be sitting right in between 15 and 17, which the only number that's in there is 16. So this becomes our median, 16. And remember to find our Q1, we find the median of our lower half. So we have 1, 2, and we're looking at 14 and 14, and there's nothing really in between there. So we are looking at 14 as our Q1, and same deal for our upper half, kind of going through, and in between 18 and 21, well, this is one of those cases where we can't really immediately think of what's in the middle. So to find that median, we take the average. So 18 plus 21 divided by 2 is going to get us directly in the middle, 19.5 as our Q3. So we have 3 out of our 5 numbers, and we just need our minimum and our maximum. So our minimum is always that smallest number, and our maximum is that biggest number. So we found the 5-number summary. There was step 1. I've already done step 2 for you. Let's look at step 3. So mathematically checking for those outliers. So we need to find the IQR first because that is our rule. Our IQR is always Q3, so 19.5 minus Q1, which will get us a IQR of 5.5. Any low outliers will be below 14 minus 1.5, so Q1 minus 1.5 times our IQR, which will get us 5.75, and any high outliers are going to be our Q3, so 19.5, plus 1.5 times our IQR. This will get us 27.75. 5. So what you want to do is look at your 5-number summary, or sorry, look at your data set and determine, is there any number that is below this number or above this number? And if we look at our data set here, we actually do have one outlier. So we have one outlier at 29 because it is above 27.75. So all we need to do is just draw the box. So we're going to draw a box around Q1. So remember, Q1 was 14 and Q3 was 19.5. So we're going to draw a box around those and a vertical line through the median. Our median was 16, so right above 16, you would draw a line. We're going to extend a line from the box at Q1 to the smallest value that is not an outlier, which we don't have any low outliers, so we don't need to worry about that. So we're going to draw a line to 13 since that is our smallest value. And from Q3, so 19.5, to the largest number that is not an outlier. So let's remember that we have an outlier at 29, so that's going to get marked as a dot. And our biggest number besides that is 21. So we're going to draw a line just to 21, and we're going to leave that done. And that is our box plot. Now, this is just some information for you to look at. When we describe distributions, we've most of the time been using histograms and dot plots and stem plots. But now we're going to actually use box plots. So we have those density curves, really just smooth graphs on the top there under the different shapes with the Q1, the median, and the Q3 listed there, and sort of what their box plots would look like as well. So really you're just looking at the distance from the median to the minimum and the distance from the minimum and the maximum, and similarly for the maximum to the median. And something to also note is that in our box plots, remember, 25% of the data is in between those quartiles and the minimum and the quartile and the maximum. So each little piece here that's sort of separated out is just 25% of the data. So it's sort of chunking it into quarters, like it says here in this note, that 25% of the data falls in between the minimum of Q1, 25 between Q1 and the median, 25 between the median and Q3, and the last 25 between Q3 and the maximum. So even though the difference between, in this particular graph, the median and Q3 is very small, it's still 25% of the data that still falls between those numbers. So just be careful with that little deceiving error there. And to finish off, we're just going to get some practice describing distributions with box plots. Notice how here, this graph, it's going from about 1 to 7, and we have that median sitting at 4. So in between, there is a distance of 3. So note here that there is a distance of 3 in between each. And since that distance in between there is equal, that means that that distribution is roughly symmetric, that it has that equal sort of shape on both sides. So that distribution is roughly symmetric. And remember, this is where we're talking about socks again, so very similar to last week. So it's roughly symmetric. It has that center where the median is, so that center is at 4 because it's sitting right there. And we need to talk about our outliers. Remember, outliers are always displayed as dots on a box plot graph. So since there are no dots, we can definitely say there are no outliers in this distribution. And we need to talk about spread. Since we don't have the actual data in front of us, we have to do the range again. So 7 minus 1 is our range. 7 minus 1, which will give us a range of 6. And we're going to follow very similar process here. Looking at this now, this is something you can definitely tell there's more of a shape difference between the two. The right side here has a shorter tail, and we have a bigger amount of values from our median to our Q3. And if we look at the axes, remember, in particular, our minimum is sitting right about here, and our median is right there. That's about a distance of around 14-ish, which means from here to here, from 50 to, let's say, like 32-ish, is about 19. So since, and again, those are approximate, since we definitely have one side that's longer than the other, that means we have a skewed distribution. So this distribution in particular is right skewed. Since that half on the right, he's a bigger amount of data sets, or data points, on that side. Its center was marked at 30 there, so where that vertical line is in the graph. Again, there are no dots here, so that means there are definitely no outliers in the graph. And if we're looking at our range here, might be easier to talk about the IQR, which is also a valid method of spread. So an IQR of our Q3, so remember Q3 is always that right side of the box, minus Q1, so maybe it's 29, I'd say, since these ticks are going by 4s each time. So this would give us an IQR of 13, and that could cover that distribution. Our last two here, one thing to note is that there's this dot out here, which is going to signify an outlier in our distribution. And since we definitely have that bigger range of values from median to maximum, then median to minimum, that is going to mean another right skewed distribution. So this distribution is also right skewed. With our center, our vertical line looks like the lines, the tick marks on our axes are going by 5s, and since our vertical line is sitting in between 10 and 20, that probably means our median, our center, is at 15. And we can talk about let's see here. Yeah, we can talk about our range. So a range, and again, these tick marks are going by 5. So let's say our maximum is, it's a little bit farther than 65. Let's call it 66. And our minimum is 0, which is going to give us a range of 66. And since there is a dot, like we said at the beginning, there is an outlier at 66. And that'll finish off this graph. And our last one, just like the one before it, there's an outlier over here on the left. which just like before, but in the opposite direction, we have one side that is much longer from median to minimum, and then median to maximum. And in this case, it's flip-flopped. So that means the distribution here is left skewed. So the distribution here is a left skewed shape. Our center now is right in between 80 and 90. So we have a center at 85. We do have one outlier, that one dot. And I'd say it's about 15 or 16. Let's call it 15. And let's use our range again. A range of, and I think we can call our maximum like 93, and we said our minimum was about 15. So let's see here, if we're looking at 93 minus 15, that's going to give us a range of 78. And that's going to finish out our practice with comparing box plot distributions. Let's see what we have next. Comparing distributions. So all we want to do is follow these steps here. You want to determine the shape. I recommend drawing box plots for these things because it's just easier to find the 5-number summary through those. If they're both symmetric with no outliers, you're going to use the mean and standard deviation. If even one of them is skewed and or has outliers, we're going to use the median and IQR to compare center and spread. We're always going to mention the range on both, as well as one of the other measures of spread. We want to check for outliers. We want to use these wordings here that I've provided for you, or at least something very similar to it. And one final note, if one of those distributions is symmetric with no outliers, that's a typo, with no outliers and the other skewed, we're not going to be using mean for one and median for the other, since they don't mean the exact same thing. So we're going to use median for both, since they mean the same thing. So we're given a random selection of male and female student data, and their height, another typo, their height in inches was recorded, and we are going to compare those distributions. So first things first, we need to get the graphs down. So if you do this in your calculator, you will end up getting your 5-number summary. So take a moment to do that. Okay, so once you've found all these numbers, these can all be found using the 1var stats command that was in the previous lesson's tech check. So go ahead, if you don't remember how to do that, go ahead and look for that. So we have the 5-number summaries for each group, we have the IQR for each group, and we have the outlier check. The one thing to note is that for males, we do have one outlier at 77 because it is above the upper limit here. So let's go ahead and do these parallel box plots. And we'll start with the female box plot first. So we want to start with the minimum. So remember our Q1 and Q3. So our Q1 is 64, and we're not going to do it too high up. And our Q3 was 68. We're going to draw that box. And we're going to draw a vertical line at our median, so 68. We are going to extend. Oh, sorry. Yes, we are going to extend to our maximum. so 71, and extend to our minimum of 62. And that's going to be our female box plot. And now our male box plot, again, we start with our Q1, so 68. So we have that box at 68, and our Q3 at 71. We'll draw that box. Notice how we're doing them on top of each other, but they're not actually touching. That's that definition of parallel coming back in. And our median at 69. We'll draw our line from our Q1 to our minimum, so from 68 to 64, and from 71 to our smallest number that is not an outlier, or our biggest number that is not an outlier, which is just going to end up being 72, with our outlier being drawn in as a dot. So since we are looking at something that has an outlier, if one of the distributions is symmetric, no outlier, and the other is skewed, we are going to be using the median for both of our comparisons. So this is where we start using context in our problems. So we can talk about whichever one we want first. Since the data of the males was first, that's what I'm going to choose. Those male heights, they are skewed, and they are definitely right skewed in this case because there is that big gap with that 77 hanging out. So that distribution is right skewed, while, and this is where we start comparing them. So while the female heights, and again inserting that context, that distribution was roughly symmetric. And already we've talked about the shape. Talking about our center here, remember we use that word overall. Males are going to end up being taller. And that's because they have that median height with a median height of 69 inches, while females were shorter. With, in this case, 66 inches. And we've talked about center. The males had one outlier at 77 inches. The females had none. And finally, talking about the spread, so talking about the IQR and the range here. So the IQR, if you compare them, you'll notice that the males had a smaller IQR. So when we say about this is we can talk about how the females, let's switch it up a little bit. Females had more variability. Remember, that's the term we use to talk about spread. Females had more variability in the middle 50%. That's talking about the IQR. While males have less. And then we also need to remember to record our ranges. So the male heights were a range of 13 inches. Well, females, their range was smaller. They had a smaller range at 9 inches. And that is how you would compare distributions for two sets of data. You could do this with histograms or dot plots, but box plots are just generally easier, so you can quickly get those 5 numbers, and then just drawing the box plot is also super easy too. But that'll do it for us today. Please let me know if you guys have any questions. Email me, message me, and thanks, guys.